Good morning, everyone, and welcome to today's webinar. My name is Don Pearson. I'll serve as your moderator. I'm also the Chief Strategy Officer with Inductive Automation Software. Topic today, Java security and ignition, getting the facts, and protecting your system. We're putting on this webinar really just to give you the information that you'll need to better understand recent Java security breaches which have occurred. And today we'll be talking about some of the basics of what Java is, how it's used at ignition. We'll also be discussing the nature of the recent security issues and how you can protect your PC. With that, it's just a little bit of background. It's really my pleasure to introduce Carl Gold. Carl is one of the lead developers of the Ignition platform. He's helped build Ignition from the ground up, and he's really uniquely positioned as an expert in the use of Java with Ignition. Couldn't think of anybody better to discuss the important topic today. And with that, Carl, over to you.
Hello, everybody. So I'm going to begin today by talking about just what Java is, cover some fundamentals that will lay an important foundation for really understanding the security concerns that we're talking about. And I'll try and clear up some misconceptions that I commonly encounter along the way. And then I'll get into explaining exactly what these security concerns are. I'm sure you've all been reading about them in the news. It's probably why you signed up for today's webinar. And so we'll go into some detail about exactly what's at risk here. And then we'll talk about how to protect your systems. It's really not too hard. There's some simple steps you can take. And then I'll briefly touch upon digital signatures and how they're used to establish trust. So let's begin with just talking about exactly what Java is. So first and foremost, Java is a programming language. Now, programming languages can be broadly divided into some categories. And so here we have a picture of sort of the traditional model of programming languages, where you have source code, and then you run it through another program called a compiler, and it produces something called machine code, which is just an executable program that can be run on some specific kind of computer. So this would be, the model that a language like C would fit under. And then you have the interpreted model, where you have source code, but you don't compile it. Instead, you have another program called an interpreter that is present on the target deployed computer, and you feed the source code into the interpreter, and it runs it directly with no compilation step. So the traditional model typically, would be considered faster since it's running directly against the CPU. The interpretive model is a little bit slower, but the advantage of the interpreted model is that you're going to gain some portability in that you won't have to recompile your source code for different platforms. Now, Java kind of uses a hybrid of these two models. It has a compiler, and Java is a compiled language, but it doesn't compile directly into the machine code of any real computer. It compiles into something called bytecode, which is kind of like machine code for an imaginary computer that's never been built. And then it uses a program called a virtual machine, this is the JVM that you're probably familiar with, to run that bytecode, which hot translates it on the fly into the machine code for whatever machine it's running on. And so this hybrid model kind of gains the benefits of both of the other models. With the modern hotspot virtual machines, you approach or match the speed of the traditional model, and you get the benefit of the portability as well. So if I want to run my Java program on a 64-bit or a 32-bit architecture, I don't need to recompile it into different 64 or 32-bit machine code. The JVM takes care of that for me. I only need to compile it once. So that's sort of the fundamental overview of how the Java language works. But by itself, a language can't really do anything without an API. Without an API, all you'd be able to do is a lot of arithmetic on the CPU, which isn't very interesting. So an API is the layer that gets you access to other resources in the computer, like the file system, the networking system, and the graphical user interface. And it's really the API layer here that makes Java portable. So let's look at what the traditional model might look like from an API standpoint. So let's imagine that we wanted to write a program that edited a file in C. So I'm going to write my program, and I need to edit a file. So I need an API that gives me access to a file system. So let's say I'm writing it for Windows. So I'm going to write my program against the Windows File API. Then I need to compile it with a Windows compiler. And I might need to compile it twice for different CPU architectures. Well, now I want to have my program run on Linux. Well, Linux's file system API is different from Windows file system API. My program won't compile unless I change it to be written against a Linux file system API. Then I have to compile it with a Linux compiler, and again for different CPU architectures. So you can see with this model that the number of permutations is really going to start adding up. And from a software development standpoint, this is costly, and it can be fairly error-prone if I'm making operating system-specific edits to an application. So the Java model looks more like this. And this, again, really is what makes Java so portable, is that Java has its own API layer. So if I want to write a program that edits a file, I don't write it against the Windows API or the Linux API or the Mac API. I just write it against the Java API, and I compile it once. And then when it's running in the JVM, it's the JVM's job to translate between the Java API and the underlying operating system's API. So this is a real big win for software developers because it simplifies our code base. So that's the language and the API. And the last thing I want to talk about to cover what Java is the deployment model. So deployment is just a fancy word for getting your computer program onto somebody's computer so that it can run. Now, traditional deployment models basically involve file copying. Maybe you put your application on a CD and you bring that CD over to a computer and install it. Well, when Java was invented, it was right when the World Wide Web was taking off, and so they had some different deployment models in mind. And so the first one that they invented in the late 90s was the applet. So if you remember the late 90s, web pages really weren't nearly as capable as they are today. They were really simplistic, right? They weren't very dynamic or interactive, and people wanted more dynamic and interactive web pages, and Java seemed like it would fit the bill. So they invented this idea of the Java applet, wherein a web page would contain an applet inside of it. When you load that web page, it's going to load a browser plugin that downloads a Java program and runs it within the web browser, giving you a more dynamic web page. Well, as time went on, applets had some success, and then the developers wanted to use a similar model for more full-fledged applications that didn't want to really be embedded inside of a web page. They kind of wanted to be more of a first-class citizen of the operating system's desktop. And so Java Web Start was invented a few years later. Java Web Start is actually a remarkably simple system from a technology standpoint. All it really is an operating system file association with the file type JNLP, which stands for Java Network Launch Protocol. And so you go to a web page, and it has a link, and you click on the link, and that downloads the JNLP file, and then it asks the operating system what it wants to do with the JNLP file, and it says, oh, I want to invoke it using Java Web Start, which then reads that file, downloads your Java program, which is packaged up into binaries called jars, and runs it. I mean, this is really identical to the idea that when you're on a web page and you click a link to a PDF, it downloads the PDF, asks the operating system what to do with the PDF, finds the file association for Acrobat Reader, and launches Acrobat. Really similar idea. And so this is a pretty simple system to understand, and it's quite effective, and obviously we use it quite a bit in Ignition. So before I go on, I just can't resist clearing up this very common misconception, which is that Java is not JavaScript and vice versa. I don't know how this snafu came about. I don't know who was in charge of naming JavaScript, but they did an awful job. So this is a really common point of confusion, and I can totally understand why, because they both have the word Java in the name, but they're not even in the slightest bit related. JavaScript is a completely different language. It's an interpreted language. All web browsers have a JavaScript interpreter built into them, and has an extremely limited API, which is actually what makes it a fairly safe language to run inside of a web browser, is that it just doesn't have the APIs that would let it become a dangerous language, in that you really would be hard-pressed to write anything dangerous in JavaScript, because the only APIs you have are limited to manipulating the web page. So again, Java and JavaScript, not even related. Okay, so there's some fundamentals of what Java is. Let's move into what you all came here for, which are what are all these security concerns that we've been hearing about in the news. So I think a lot of people, when they read headlines about how insecure Java is, kind of conjure up this picture inside their head, which is that, well, if Java is insecure, what that means is, well, if I run a Java program, then I'm vulnerable to some sort of attack, in that the Java program itself is insecure. It's vulnerable to an attack from the internet. I'm going to get attacked, and it's going to spread to other PCs on my network. Okay, that picture is not at all what anybody is claiming these security concerns are about. And this is a really important distinction. Before we talk about what the security concerns are, we need to also make sure we understand what they are not. So, you know, by running Ignition, you are not vulnerable. Ignition itself isn't really vulnerable at all. The vulnerability that we've been reading about actually all comes down to that deployment model. You know, Java itself as a language can't really be considered secure or insecure. It's just a tool. You know, you can write useful applications like Ignition in Java, and you can write viruses in Java, just like you could write viruses in C. And nobody thinks of C as secure or insecure. So the insecurity comes in with this deployment model, specifically the applet deployment model. So if you really think about what I was describing before with how applets work, it should really raise your eyebrows a little bit. So here you are in your web browser. You're browsing the web, and a web page you visit says, oh, I've got an applet inside of me. So go ahead and download this program and run it for me, please. Now, if you visited a web page and it popped up something saying, hey, this web page wants to run me.exe, you sure wouldn't let it, because it would be a pretty obvious ploy to install some sort of virus or worm or whatever on your PC. But in some sense, that's what applets are. They're running programs, Java programs, inside your web page. And this is fairly obvious, this vulnerability, and it certainly wasn't lost upon the designers of the applet system. And so what they did to make applets secure was they invented this idea called the Java sandbox. So the idea goes that when you run an applet, which is just a Java program, it will only have access to a very limited set of the Java APIs. Again, we come back to the importance of understanding how the APIs are really what give a programming language its power. So by running inside the Java sandbox, that's part of the Java browser plugin, you don't have access to the file system API if you're an untrusted applet. And we'll later in the talk get into what trust means. But if you're an untrusted applet, you don't have access to the file system API, you have limited access to the networking API, etc. Well, here's the problem. These security concerns that have come to light in the last few months have brought out the fact that the sandbox, which is kind of like a wall around the Java program that you're running inside your web page, just doesn't work as advertised. And so there are exploits that you can use to fool the Java browser plugin, break out of the sandbox, and now you're just a full-fledged application running without the consent of the user, and you can see how this could be used for an attack. So again, the security concerns aren't that running a good Java program is somehow dangerous. The security concern is that by having Java on your system and having your browser plugin on your browser, you're just opening yourself up to having malicious programs executed on your computer if you go to the wrong web page. All right, so how do you protect yourself from this? Well, you've got option one, which is just completely disable Java applets, basically disable the deployment models. Well, this would be effective, except it'll preclude you from using Ignition conveniently, so we really don't recommend it. You could still use Ignition, but you're going to have to make some shortcuts, and it really is going to detract from the usability of our web launch system. So our suggestion is to change the Java security settings to simply not run untrusted programs. Again, the issue here is that untrusted programs, untrusted applets in particular, that were supposed to run in the sandbox, break out of the sandbox and get into your system at large. Well, just don't run them at all. Don't even execute them. This is the new default security setting for the new versions of Java anyhow. And we think it's a good idea because, after all, Ignition is a perfectly well-signed and trusted application, so this won't affect running Ignition at all. If that is not sufficient for you, you're still not convinced, another option would be to completely remove the Java browser plugin from your browser. This is just sort of yet another step to remove this vector of attack so that you can't use applets at all. And very few of our customers use applets. Most of our customers use Java Web Start. So this would be an effective way also to protect yourself from these problems. And lastly, it's really important to try and keep Java up to date. This isn't quite as important on the server machines here. We're talking about client machines or client workstations. Because, you know, hopefully there aren't humans that are browsing the internet on the server machine, which is again, where the vulnerability presents itself. So keeping Java up to date is important. After all, Oracle has fixed this problem already. So Java 7 Update 15 has all these problems fixed in it. So if you kept your Java up to date, you'd be all set. Okay, so we keep talking, or I keep talking, about this idea of trust. You know, don't run untrusted applications, only run trusted applications. Well, what does that mean? How do you know, how does your computer know what's trusted and untrusted? And this is a big topic that I'm going to be breezing through fairly quickly. And if it piques your curiosity, there is lots of literature about this that you can find on the internet. But briefly, I'll try and describe a fairly complicated system. And it all rotates around this idea of digital signatures and public-private key pairs. So the way this works is that anybody can go and generate something called a key pair, which is a pair of keys. And these keys are linked to each other in a very special way from a mathematical perspective. So the keys can do two things. Given a piece of data, which could be a document or an application, you can create a signature for that data that is unique, both to the key and to the data. You can also use a key to verify a signature, both verifying that it matches the data and was made by the opposite key in the key pair. So the way this typically works is that you generate a key pair and you keep one private. You don't let anybody have it. It's private, internal to your organization. And then you make the other one totally public. You post it on your website. You can give it away to anybody. So now you have data, and you want to make sure that people consuming your data can be convinced that it hasn't been tampered with and that you made it. Okay, so you create a signature for your data. You take your unsigned data and turn it into signed data by attaching a signature using your private key. Then anybody can go and use that public key and can be guaranteed that the data, if the signature matches the public key can tell whether or not the signature matches the private key without having the private key in your possession. So again, you use the public key to verify and use the private key to sign information. Okay, so this is sort of the underlying mechanism, but we still don't have a full trust picture here, because after all, how do you know the holder of the private key is who they say they are? So for example, when we make a key pair, we say it's owned by Inductive Automation, but what's to stop some nefarious actor from making another key pair and also saying it's owned by Inductive Automation? All right, this is where the picture gets a little bit more complicated. Now we enter the idea of a certificate authority. So there's a few companies in the world called certificate authorities who are in the business of brokering this trust. And the way they've done this is that they also have their own key pair. They have their private keys and their public keys, and they've positioned themselves in such a way that their public keys are pre-installed on every computing device in the world, which is why they get to do what they do. And so this is important because your computer already knows the public key of, let's say, VeriSign, for example, and therefore it can trust that anything that was signed by VeriSign's private key, it knows that it can validate that signature without the keys being transferred over the network, so it knows nobody's tampered with these keys. All right, so here we are at Inductive Automation. We need to make a trusted application. So we make a key pair, and we keep our private key private, and we send our public key to a certificate authority. And we say, hey, certificate authority, here's our public key. You can see that it's annotated as being owned by a company called Inductive Automation. And their job is to vet us out. They call us, they do a little bit of digging, they make sure that we really are a real company called Inductive Automation, and that whoever is submitting this request for a public key certificate really works there and is trusted by us. So they do their job, and if they're satisfied, they issue what's called a certificate. And crucially, that certificate is then signed by their private key. All right. So in this picture, that's the blue box with the orange key inside of it. That is our public key wrapped up in a certificate that is signed by VeriSign's private key. So then we make Ignition, and we need to sign it. So we take our unsigned program, which is called a jar file, and we sign it with our private key, and we include inside of it our public key wrapped up in VeriSign's certificate. So by the time this whole application gets to your computer can establish trust in the following way. It looks at this application, and it looks inside of it, and so it sees that it's signed, and it has a certificate. And so step one is that it can verify that the certificate's valid. It can verify that the certificate was signed by a certificate authority that the computer trusts. All right. If it's satisfied that it's a valid certificate, now it has the public key, because our public key, which is embedded, that's the orange key here, embedded inside of the certificate. It then can use the public key to validate the signature on the application itself, which then lets the computer trust that the application has not been tampered with by any third party. So it knows that we, Inductive Automation, as holders of our private key, created and signed that application. And that is how trust is established. So this brings me to the end of my section here. And just in summary, you know, it's important to remind ourselves why we even bother to use Java. And so in case it wasn't self-evident from the rest of the talk, one of the top reasons is the portability. You know, this is a really big win for us and our customers. This portability lets us run Ignition on Windows and Mac and Linux, which is just you know, very important to a lot of our customers. And there's kind of a soft compatibility we get from this as well, which is that we are kind of insulated from all the different versions of Windows. So, as Microsoft releases new versions of Windows, APIs change, and we're pretty well insulated from those changes. So, for example, when Windows 8 came out, it was practically zero effort on our part to validate that Ignition worked on Windows 8 because basically Oracle did that work for us when they made their JVM. And secondly, we gain a lot of benefit from just how widespread and popular Java is. For 8 of the past 10 years, Java has been the most popular programming language in the world, and that confers a bunch of benefits. So it's very well supported. It's pretty easy to find talent for Java programmers, and it leads us into number 3, which is that there's a really, really wide availability of third-party libraries that we can incorporate into Ignition, which helps us stay lean and expand the capabilities of Ignition more cost-effectively. And lastly, we just want to put in a good word for Oracle as stewards of Java. When Oracle bought Sun a few years ago, it was a little bit of confusion. What would this mean for Java? And it turns out that it's been very good for Java. Oracle has really picked up the torch and ran with it, and we're very happy with the way that they've been treating Java. And so these are all factors that let us stay nimble and make Ignition the product that our customers, you guys, all demand.